Okay, this lesson, which you may be seeing without me here, should not be that tough for you anyways. I'm sure most of you think that you understand this stuff pretty well, but it's somewhere down the road of solving equations, most of you kind of stop being able to do them very well. So we're going to go back and we're going to work on this from the beginning until we get it right. So in solving equations is where math becomes abstract. I mean, up till making variable expressions and solving equations, everything is arithmetic, and that's fairly concrete for most of us, right? If I say 2 plus 2 is 4, that's just basic arithmetic. When I start to say 2 plus some number you don't know that I'll call x equals 4, that's abstract. Now that one is one anybody in here would get immediately. But as the equations get more complicated, like this is a quadratic equation, that's tougher, right? We need strategies to solve that. Or even something like an exponential equation, 10 to the x equals 1,000. You may be able to solve that one in your head. But the bottom line is, you know, for every kind of equation that there is, we may need some different strategies. Now, solving equations, we solve equations at this step in our development by trying to isolate a variable. And we isolate variables by using properties of real numbers, things like combining like terms, distributive properties, and what you would call the properties of equality, which I'll review a little bit in another slide. But we apply these things in a systematic way to isolate a variable on one side of the equal sign, and we expect the other side to be the answer. This is, besides being specific practice and how to solve equations in math, is supposed to be an exercise in problem solving. And you may not use math beyond the bare minimum in your life. But if you aspire to have any kind of meaningful job, you are definitely going to have to solve problems. And by solving problems, we mean you have to take the tools that are available to you and put them together, sometimes in unique ways, to come up with a solution. I mean, you could ask most of your parents, certainly you could ask me, most times when you go to work in the morning, what you think you're going to do is not what you end up doing that day. And that's what we mean by problem solving. I mean, you may have had to solve a problem around the house where you take something that wasn't really designed for that purpose and you made it into a tool that you could solve that problem with. But those kinds of general skills at problem solving is really what we're trying to get at when we learn to solve math equations. So even if you don't go on a calculus track, this is supposed to be some practice at how do we solve problems in general. Now, the properties of equality, you could read all that and not quite understand what they're saying so much, but I think probably you would. The addition property of equality just means you can add the same thing to both sides of an equal sign and not change the equation. The subtraction property of equality means you can subtract the same number from both sides of the equal sign and not change the fundamental equation that you started with. What they call it an equivalent equation. But, you know, this is just the basics, right? What is the solution of? And -7 equals b minus 3. We are trying to isolate the b, right? There's the b. Let me write it down here. -7 equals b minus 3. The b is not isolated. It's not alone on that side of the equal sign. So the first question you have to ask is, what is with the b? And it is a 3, right? And the 3 must be moved. Okay, well, how is the B affecting the 3 affecting the B? It's being subtracted from B. So in order to move it, you need to do the opposite or the inverse operation, right? So we would add 3 because adding is the inverse of subtracting. And if I add it to one side, I add it to the other. And to be very systematic about this, you should be showing that step, just like I did right there. You should show a place where you added 3 to both sides of the equal sign. And then you add both sides. -7 plus 3, -4. -3 plus 3, 0. So the answer is B equals -4. Because B is isolated, that means the answer is on the other side. Okay, M minus 8 equals -14. What is with the M that has to be moved? And you're going to say there's a -8. Okay, what's the inverse of subtracting 8? And you would say adding 8. And you would show it. M and that -8 plus 8 cancel. -14 plus 8 is -6. And they said check your answer, meaning check your answer means put that -6 here. -6 minus 8 is -14, so that's a check. Okay. And this 1/2 equals y minus 3/2. Okay. What is with y that needs to be moved? And there's a 3/2, and it's being subtracted. So how do I move it? I add 3/2 to both sides. Okay. What is 1/2 plus 3/2? This is adding fractions that already have the same denominator. Right? That would be 4/2. -3/2 plus 3/2 is 0, so that is y equals 4/2, or y equals 2. Again, you can check it. If you checked it, you would have to put the 2 in for the y. That would be 2 minus 3/2. And you need a common denominator now. Since that has a denominator of 1 and that has a denominator of 2, you would multiply by 2 over 2. You would get 4/2 minus 3/2, which is 1/2. Check. We also have multiplication and division properties of equality, which again means you can multiply both sides of an equation by the same number and you still have an equivalent equation. The division property says you can divide both sides by the same number and you still have an equivalent equation. So 4x equals 6.4. Solve for x. Isolate the x. What is with the x that needs to be moved? And the answer is there's a 4. How is the 4 operating on the x? I mean, what is going on in between the 4 and the x? It's a multiplication. Okay, what is the inverse operation for multiplication? The answer is division. So divide by 4. But if you divide one side by 4, you divide the other side by 4. And 4 over 4 cancel. We get x equals 6.4. Sorry, edit. X equals 1.6. Now, if you looked at that 4 over 4 and said, well, that's 1. That's 1x. You know, that is absolutely correct. But what is 1 times anything? And the answer is it's that same thing back again. So you should not write 1x, or you should not leave your answer at least with a 1 times x, right? Just write x equals 1.6. Okay, 10 equals 15x. So in this case, there's a 15, which is multiplying times the x, so you divide both sides by 15. So now the 15s cancel. We get x equals 10 over 15. Okay, simplify the fraction. It is not 100% correct unless you simplify this fraction. And in this case, that will be, there's a 5 divides, this is 5 times 2 over 5 times 3. So this is 2/3. And this one, divide by negative 3.2. Divide by negative 3.2. V equals, okay, the negative 3.2's cancel. 14 over. The fact that we're not using calculators in this class makes this a little different. But, one thing we could do is we could multiply the top and the bottom by 10. Then we would get negative 140 over 32. And then from there, you could try to simplify by dividing out common factors. Let's see. I think 4 times 35, that would be, there's a negative in front of the fraction. That's 4 times 35 divided by 4 times 8. The 4's cancel. Negative 35 over 8. Now this is a kind of problem where like I say, I think a lot of you are not going to be challenged at all by the solving of 1 and 2-step equations. But where we make the most mistakes later on solving equations is when we run into something that looks like this. Or maybe it'd be written like 1/4 x equals negative 9. Those are the same thing. Those say the exact same thing. And we get confused about that sometimes. Now, dealing with the one we were given with, what is with the x that has to be moved? And the answer is it's being divided by a 4. So what is the inverse operation of dividing by 4? Multiplying by 4. 4 times x over 4 equals negative 9 times 4. Cancel, x equals negative 36. Right, same thing. R over 3 equals 19. The R is being divided by 3, so we're going to multiply times 3. 3's cancel. R equals 57. Right, x divided by negative 9 equals 8. X is being divided by negative 9, so we're going to multiply by negative 9. Negative 9's cancel. X equals negative 72. Okay, this is the one place where you got to learn how to do this like I'm telling you to do it now. 4/5 is clearly multiplying times m. And your instinct may be that you need to divide by 4/5. And that's not altogether wrong. It just that dividing by a fraction, which is something we already practiced in chapter 1, is the same as multiplying by the reciprocal. And that's really what you want to do, right? You don't want to divide by 4/5. You want to multiply by 5/4. Right, so if I multiply 5/4 times 4/5 m, 5/4 times 28. So I multiply both sides by the same thing. That's multiplication property of equality. And now 5/4 times 4/5, right? That's the inverse property of multiplication. Or you could just 5 cancels 5, 4 cancels 4. It's all 1. So m equals, and then 4 goes into 28 how many times? 7. So that is 5 times 7, 35. So don't divide by 4/5. Multiply times 5/4. Okay, this is going to come up over and over again as our equations get more complicated. We will have many, many times where that is going to be just part of solving an equation. So again, if take that advice to heart, what would you do on this problem? Right? There's a 3/4 multiplying times x. What will you do to both sides to solve the equation? And the answer is you're going to multiply by 4/3. Right? 4/3 times 12 equals 4/3 times 3/4 x. Right? These cancel. And 3 goes into 12 4 times, 16. Now, a two-step equation means you're going to have to do two things to isolate the variable. Right? In this one, there's 2x plus 3. To isolate this x, you're going to have to get rid of the 2 and you're going to have to get rid of the 3. The only question is, which one do you do first? And this has got to be part of your instinct. What's the right thing to do? My guess is that most of your instinct is correct on this one. And the way I look at it is, if there's more than one term, you want to get rid of the terms that don't have the variable in it. So in that case, let's get rid of the 3 first, and then we'll worry about the 2. Okay, well, the 3 is being added, so in order to move it, we need to subtract from both sides. So 2x, 3 minus 3 is 0, 15 minus 3 is 12. Okay, now you have a 2 times x, you need to get rid of the 2. So the inverse of multiplying times 2 is dividing by 2. So x equals 6. And again, not a bad idea to check your answer. 2 times 6 is 12, plus 3 is 15. Check. Let me write this. 5 equals t over 2 minus 3. So the variable is t. It's on the right-hand side. There's two things going on. It's being divided by 2, and it's being subtracted by 3. All right. Now that's two different terms. So like I said, the first step would be, let's add 3 to get rid of the term that doesn't have the variable in it. Add 3. So we have 5 plus 3 is 8 equals t over 2. And the 3's cancel. Okay, you still have t is being divided by 2. What's the inverse operation? Multiplication. So we will multiply both sides times 2. And the 2's cancel. T equals 16. And just in case you're not sure, because this comes up every once in a while, if it says 16 equals t, I mean, you can reverse that and say t equals 16. That's a symmetric property. Now, here's where it gets just a little more interesting. x minus 7 divided by 3 equals negative 12. And the question would be, there's two things that are with x that you have to undo. You've got to minus 7 and you've got to divide by 3. Now, how many terms are there on the left-hand side? And there's only one, right? There's only one term, because these, when you have a fraction bar like that, that is like grouping the x minus 7 together in one fraction. So the first operation you want to do is, since that 3 is dividing the entire left-hand side, multiply to get rid of that denominator first, right? You can't deal with the negative 7 until you get rid of the 3 first. So multiply times 3 times 3. Right. Now that cancels the 3. You still have x minus 7 equals negative 36. And then last step, how do you undo a minus 7? You add 7. So that'll be x equals negative 29. Then you could check. Negative 29 minus 7 is negative 36. Negative 36 divided by 3, negative 12. Negative t plus 8 equals 3. So what are it's a two-step operation. So what are the two steps two things that you've got to take care of here? Well, you've got to take care of the plus 8, and you've got a minus in front of the t. So those are the two steps that you've got to take. So let's do the first one, which is subtract 8 from both sides. Negative t equals negative 5. Now the question is, how do we get rid of the negative, which is in front of the t? And you could think of it, I think if you looked at the example in the textbook, which we're not really carrying around anyways, they look at that like it's a multiply times negative 1, and they divide both sides by negative 1. I don't. If you remember when we did the properties of real numbers, we had a property which was the negative 1 property of multiplication or something like that. It said that if you multiply by negative 1, it flips the sign of everything. So what I would do, I'd much prefer to just think of it as a multiply times negative 1. So if I multiply this side by negative 1, then I have to multiply the other side by negative 1. Negative 1 times negative t, the minus times minus makes plus. It flips the sign. And the negative 1 times negative 5, positive 5. So you're not altogether wrong to think of that as a, let's divide by negative 1. I like to think of it as a multiply times negative 1. And this is probably the last example. So two things going on here. The x is being divided by 3, and there's a 5 subtracted after that. So what would be the first thing I get rid of? You know, it ought to be the add 5. X over 3, the 5's cancel, equals 9. And then x is still being divided by 3, so the inverse of dividing by 3 is multiply times 3. 3's cancel, x equals 27. Now, sometimes what I see is that I think students who are not really very good at solving equations will instead try to multiply times 3 first. And at this step right here, you're going to decide to multiply times 3. You can do that. I mean, there's nothing wrong with multiplying times 3 first, as long as you do it correctly, right? And when you multiply both sides times 3, let's say that that's the way that I go, then it should look like this. 3 times x over 3 minus 5 equals 3 times 4. Now, this is a distributive property. You're going to have 3 times x over 3 minus 3 times 5 equals 12. What we usually see is when you decide to multiply times 3, you multiply this by 3. You multiply the x over 3 by 3, but you forget to multiply the 5. Now, like I would not have done that first anyways. I would have added the 5, and I wouldn't have had the same issue. But if you go this route and multiply times 3, you've got to remember to multiply both sides, and that means every term by 3. 3, 3, 3. So this one is, the 3's cancel, x minus 15 equals 12. Add 15. X equals 27. So solving one-step equations and two-step equations. Homework from the workbook. Those are not the hardest problems in either one of those sections, but I expect we'll go back and do the harder problems probably next class.